So I will be talking about cryptography and Elixir. Cryptography is a topic that I got interesting in the last 2 years, maybe, and it is a very interesting topic for me. And I also like a lot Elixir, so this is why I choose to make a talk about it here in the ElixirConf, and I am glad they accepted it. So let's start talking about the agenda. What we'll be talking about. First, we will be talking about why is cryptography important and why you should, as a developer, be interested in learning more about it. Then we will be talking about the basic knowledge that you as a developer should have. Then we will be talking about how things can go wrong. This is a phrase that I copied from a book that I read called Series Cryptography that I like. I like it very much. And in this part, we will be talking about how can you misuse cryptography. How could you mm, use the algorithms in a way that harms you or harms your project. The next thing that we will be talking about is how to use cryptographic primitives and algorithms in Elixir. What options do you have to use these things that we talked about? And for and last but not least, we will be talking about what's next for you. What could you do in order to improve your knowledge about cryptography? But first of all, if you don't take any other thing about this talk, I want you to go out with two main advices. The first thing is that learning how or when to use the basic cryptographic devices or basic cryptographic algorithms gives you an advantage point against those people that wants to take advantage of your information or what wants to steal your information. So you need to learn how and when to use these cryptographic devices. And the second thing is that you need to think always that the failure of you or the success or failure of your platform, your product, your business is dependent on its security. In this time that the all the world is constructed upon digital tools, security is superlatively important for this for all these products. So if your product isn't secure, maybe it is completely a failure for you. So let's start talking about why is cryptography important for us as developers. But for this, we need to understand first what is cryptography, and second, why is cryptography? What is the reason of existence of cryptography? Cryptography comes from the Greek. The easiest way of explaining what cryptography is using its etymology, and it comes from the Greek. It is composed by two roots. First is crypto, that means hidden, and the second is graphene, that means to write. So cryptography is the art of hidden writing of the secrecy. Some some people call it the art of concealing information, and I would like to share with you uh, the definition that I found in a book written by David Wong, a great cryptographer that is working on TLS3 1.3, and he says that cryptography is the ancient discipline of securing situations that are troubled with malicious characters. I highlighted here malicious characters or situations that are troubled with malicious characters because everything we do in cryptography has something to do with others, with people that wants to harm us or that wants to take advantage of our information. So the another definition that David gives in his book is the science of aiming to defend protocols against saboteurs. So again, I highlight against saboteurs because you are always thinking of who can take advantage of your information, and this is a very important part to think about your system and how strong your cryptography needs to be in order to defend against someone that wants to take advantage of you and your information. So imagine that you have a financial platform. Maybe something is very interested in stealing the passwords of the information that is there because he could use that information to steal money, for example. So that attacker would be very interested in stealing your information. In order to protect against that, you need to use the best algorithmic cryptographic tools in the world. So that is why it's important to think of who want to take advantage of that information. Um, another quote that I would like to mention here is a book that is in a book called the Code Book by Simon Singh. That he says that cryptography has decided the outcome of battles historically. The generals and the military has used cryptography to communicate with remote generals, for example, and the failure of these algorithms or of this communication or secret communication has led to deciding battles and also the death of kings and queens. So complete empires have been fallen because of the failure of secrecy. So in this world, in this era, our digital security and authenticity relies completely on cryptography, and we programmers, as the builders of digital world, are obliged to know how to protect our creations. So if we fail to do that, we will be very in trouble. So let's start by talking what is the basic knowledge you should have in order to protect your development against malicious attackers or against saboteurs. First, let's start talking about basic concepts. What are the basic concepts that someone needs to have in order to handle cryptography in the best way? In this presentation, I selected only three main concepts that you need to know and you need to think about in order to think about what do you need about cryptography in your development. So the first one is authenticity. Authenticity in few words is knowing who are you talking to, but you need to know for sure that you are talking uh, to the person that you are intended to talk, or to the server or to the entity that you are intended to talk. This is called authenticity, and it's a very important uh, cryptography concept. The second concept that I want to mention here is confidentiality. Normally, when we think about cryptography, this is the first concept that we have. We think that cryptography is all about hiding information, but not everything in cryptography is about that. But it is one of the main things that we need to think about. So confidentiality means hiding information from for someone that doesn't need to know that, or we don't want he to know that information. So this image is about a lizard hiding in plain sight. The third part of the main concepts of cryptography that I want to mention is about integrity. Integrity is having information or conveying information to others exactly as we mean. So this information isn't tampered in some way. This information isn't incomplete. This information isn't changed. That's integrity. So these three concepts are the main concepts that give us security in our digital world. Knowing who are we talking to first. Second, hiding information for people that doesn't need to see it. And third, knowing that the information hasn't been changed or hasn't been tampered with. So, what cryptographic primitives you need to know how to use as a developer? I will mention first the cryptographic primitives or the algorithms that you need to know, what these algorithms do, and how can you use it briefly. And finally, what is the current state of the art in this type of primitive? What should be used in your development? First, the most basic cryptographic device or algorithm or primitive is the hash function. Gianfilippo Masson, the author of the book series Cryptography, called hash functions the Swiss Army knife of the cryptographers because hash functions are everywhere. The hash functions are known as also as one-way functions. Normally, hash functions receive a variable size input, so you can give a hash function gigabytes of information, and the hash function will output a fixed size output like 256 bits, for example. A hash function, I use this image to illustrate a hash function because it receives something and it completely mashes it, and you cannot retrieve what you sent to it from the output. So this is the importance of hash functions. uh, one of the things that, because hash functions are important, is because you could build more complicated or more complex uh, cryptographic devices above these hash functions. Hash functions, as I said, are user everywhere. For normal hash functions, the faster the better, because everyone wants things faster. So the less consumption, the less memory they use, the better for normal hash function. For this, you you don't you shouldn't be use SHA-1 that it's already broken or half broken. You shouldn't be using SHA-2 because it is more or less broken, because you can attack SHA-2 with length extension attacks. You could use SHA-2 in some situations, but the currently recommended standard is SHA-3, with 256 bytes. This is the recommended standard for current developments. The next types of primitives that we'll be talking about is password hash function. This is a special case of hash functions that has some requirements for us to use securely. The first requirement for hash function is the slower the better, because we don't want some attacker that has a complete database of a lot of passwords that he retrieves quickly, or he tests a lot of inputs quickly to recover the password or to find what is one of the inputs that could generate that hash. So this is the first requirement. The slower the better for hash functions, for password hash functions. The second is that these hash functions must be difficult to attack with a lot of memory. So some of the functions are parallelizable, and if you have specialized software or hardware, you can attack even faster this hashed password and retrieve it easily. So these password hash functions normally are customizable. You can decide how much memory they use or how slow they are. And normally, modern password hashing functions have a better developer experience because they provide sensible defaults already. So you don't need to worry about how slow should it be, or how big the memory should it be to work. The current standard is Argon 2. If you are very preoccupied for the security of your system, or you have something very sensible, you need to be using Argon 2. Argon 2 BI is the normal, is the standard, or you could be using bcrypt. The disadvantage of bcrypt, that is the current algorithm in Phoenix, is that it is it could be attacked with specialized hardware. So if you have something very sensible, I recommend you to change that default to Argon 2, that is not attackable by specialized hardware. So in order to protect your passwords in the best way. The next thing that we'll be talking about is key exchange. The key exchange are a way to interchange a shared secret with another party. Key exchange by itself aren't very useful, because if you don't have authentication, if you don't know who are you talking to, you could be talking or interchanging secrets with someone malicious. But combined with authentication, key chains are the main thing that you do in internet when you create a secure connection. Normally, this isn't something that we choose, and the current standard is elliptic curve Diffie-Hellman. The next thing that we were talking about is symmetric encryption. This is symmetric encryption is the strongest encryption that we have available today. These are the strongest ciphers. So in most cases, when you are ciphering or encrypting something for yourself, for example, in the future, or encrypting something for storage in some way, you should be using a symmetric encryption algorithm. This symmetric encryption could be working as encrypting blocks of information, or a stream of information. So you use this cryptographic device to encrypt and decrypt with the same key. The important thing here is that the 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 algorithm is as strong as your key. So if you choose a 128-bit key, the algorithm will provide 128 bits of security. If you choose a 256-bit key, that algorithm will provide the same security. So the current standard here is AES-256, that uses a key of that length and a block of that length. So in order to protect yourself against the most powerful attacks today, you should be use AES-256 in most of the part. The next part that we'll be talking about is asymmetric encryption. I use this image because someone thinks that asymmetric encryption is strong, but is not even far close to symmetric encryption. This asymmetric encryption is also known as as public key encryption. You normally generate a pair of keys, a public key and a private key, and you could use one of these keys to cipher, and another of these keys to decipher. Normally, in current status of the industry, we only use this asymmetric encryption in order to do a key exchange, and then we shift to something more secure, as example as ICE encryption. The current standards are RSA OIP and cryptographic protocol called ISIS. This is the normal way of operate of all of when we want to communicate with someone that in this way we normally use we what is called a hybrid a hybrid encryption. First, we generate a key pair, then we exchange a secret with this second party, and after exchanging a secret long, normally long key with this new party, we switch from asymmetric encryption or public encryption to symmetric encryption. Use another device called authenticated encryption that we will be talking about. Authenticated encryption is the most secure way of communicating with someone. It provides the three things. Normally, it provides integrity, authenticity, and confidentiality. It is the for the all the algorithms that we mentioned as far as now. It is the only protocol that gives all three, because it provides with the ciphertext and authentication text and sometimes with associated data that you could use to verify that the data is the integrity of the data. So authentication encryption is the most used of algorithm on internet. Normally, when we establish connection with some third party, we first make a key exchange, and then we switch to authenticated encryption with using normally ISGCM, cha 20 poly, 20 poly 1305. These two algorithms are the current standard. ISGCM is known for being strong, and cha 20 poly 1305 for being fast. So if you have limited resources, you want to use cha 20. And last but not least, we will be talking about digital signatures. The digital signatures is works like pen and paper signatures. You know for sure you who are talking to, and the normal standards are ECDSA or EDDSA, that are digital signatures algorithms based on elliptic curves. And how could you misuse these cryptographic devices or cryptographic algorithms? How things can go wrong? The first and the most common way of misusing these algorithms is a poor source of randomness. If you remember, I said that, for example, the how strong is your symmetric encryption depends on how difficult it is to guess your key. Normally, these keys are generated in a random way, and if this part is weak, all of the encryption that you do will be weak. So, in order to use algorithms correctly, you need to get a great source of randomness. Normally, the operating system as Linux will give you a pool of randomness that is great. But if you have concerns about how well will it be behave, how well it is, you need to get another source of randomness. For example, as Cloudflare that use analog device. The next part is misusing a cryptographic algorithm. Some of these algorithms needs special data to work. For example, some of these algorithms need what is called a nonce, a value or a number that it use only one. It uses only one. If you repeat this number, you break completely the security of the algorithm. So you need to know how to use that algorithm. You need to know and to read and to learn how to use that specific algorithm and use it correctly. We cannot talk about all the ways that you could misuse some algorithm. So you need to investigate and to learn how to use that correctly. But this is something that you need to have in mind. And The last part is using the worm protocol or primitive, or as we say, using the worm tool for the wrong job. Because if you use, for example, only encryption, normal encryption, when you need authenticated encryption, you will be, for example, talking to someone or interchanging secrets with someone that you know you don't want, and that will be very harmful for you. And finally, we will be talking about how to use that cryptographic protocols and primitives in Elixir. I will be talking about different layers. I first recommend that you use a library or a module that uses that that cryptographic algorithms for you, that configures it in ways that you don't want to touch these algorithms directly. For example, block crypto, you see in Phoenix and other things, and common in that is specific for password hashing. If you need something even something more of a low level, you want to use Cloak or Xcrypto. That is a subset of all these algorithms that you could use. Cloak gives you sensible defaults that you could use in order to protect yourself, and don't think too much about how to use that cryptographic algorithms. And finally, if you want the most low level cryptographic algorithms, you could use Crypto, the Erlang crypto library. Finally, what's next for you? What could you do in order to learn more? I recommend very much this book, Real World Cryptography by David Wong. It explains the current state of cryptography in our world, and I would recommend this book very much. Another great book is Serious Cryptography, that it's a bit more profound and a very enjoyable book. And I recommend, if you want to learn the most low level details about cryptographic algorithms, CryptoPulse Crypto Challenge, that is rated by Thomas Patek, it's a great resource of learning. And that's all for me.